Hello everyone, and welcome. I'm excited to kick off today's presentation. We'll be exploring the Wastewater Pumping Certification Study Guide. This is a comprehensive resource designed to help you prepare for your wastewater operator certification exams. It covers grades 1 through 4, including questions, answers, and technical references. Over the next few minutes, we'll review what this guide includes and how it can support your certification journey. Let's get started. Today, we're going to explore what you'll master in this course, starting with basic water hydraulics. We'll dive into concepts like pressure head, friction head, and pump head, which are essential for understanding how water moves through wastewater systems. Grasping these fundamental principles of fluid dynamics will give you a solid foundation for everything else. Next, we'll cover centrifugal pump theory. Here, you'll learn about the different components of centrifugal pumps, how they operate, and the physics behind centrifugal force, something that's critical in wastewater treatment when moving large volumes efficiently. We'll also look into maintenance and troubleshooting, emphasizing proper lubrication techniques, how to replace components correctly, and systematic approaches for solving common problems. This knowledge ensures your systems stay reliable and operate smoothly. Finally, we'll explore specialized equipment. This includes positive displacement pumps, turbine systems, and other specialized units tailored for specific wastewater applications. Understanding these will help you select the right equipment for different scenarios, enhancing your overall mastery in wastewater systems. All these topics are interconnected and form the backbone of effective wastewater management, so mastering them will prepare you for real-world challenges. Let's take a closer look at some essential head measurements in fundamental hydraulics. Understanding the different types of head is really key to effective pump operation. First up is friction head, which is the energy, measured in feet, needed to overcome resistance as fluid flows through pipes. This tells us how much energy is lost due to friction. Next is pressure head. This measures how high a liquid can be lifted vertically simply based on pressure. It's a way to quantify the capacity of a pump to lift water. Then we have pump head, which is the total energy, again in feet, that a pump supplies to a fluid to keep it flowing. Now, let's connect this to atmospheric pressure at sea level. Here, atmospheric pressure creates some important measurable values. For example, a total vacuum of 30 inches of mercury means that's the maximum vacuum you can achieve at sea level. Also, the same atmospheric pressure can support a column of water about 34 feet high, meaning if you had a water column this tall, it's balanced by the atmospheric pressure pushing up from below. These fundamental relationships, like the vacuum and water column height, are the foundation for all our pump calculations and system designs. They help us understand what's possible and how to optimize our systems for efficiency and effectiveness. Let's start with an overview of centrifugal pumps. These pumps are the go-to choice in wastewater applications because they are known for their reliability and efficiency. They are particularly effective at handling flows that contain solids, making them ideal for treatment facilities. Essentially, these workhorses convert rotational energy into fluid movement through centrifugal force, which is a powerful way to move large volumes of wastewater efficiently. Moving on, one of the reasons they are so widely used is their robust design. Centrifugal pumps are the most common type you'll find in wastewater treatment plants. Their versatility allows them to adapt to different flow conditions and solid contents, which is crucial in real-world applications where conditions can vary. Now, let's talk about sealing systems. Seals are essential because they prevent air from leaking into the casing around the pump shaft. This is important for maintaining efficiency and protecting the pump's internal components. The stuffing box assembly plays a key role here. It holds the lantern ring, also called the seal cage, and packing. Together, they work to control leakage, ensuring the pump operates smoothly. Finally, the packing gland is a vital component in this sealing system. Its main function is to apply even pressure on the packing material around the shaft. This creates a controlled seal that minimizes leakage, which is important for lubrication and preventing water loss. Properly adjusting the packing gland helps maintain the pump's efficiency and longevity. Connecting all these points, Understanding how centrifugal pumps work and how their sealing systems are maintained is fundamental to ensuring reliable wastewater treatment operations. Let's take a closer look at the different types of impellers and their applications. First up, we have closed impellers. These are used mainly for pumping clear wastewater with minimal solids. They feature shrouds on both sides, which helps maximize efficiency. You'll find they are ideal for situations where clean water is required and high performance is essential. Next, we have semi-open impellers. These are quite versatile and are the go-to choice for medium-sized solids. They strike a good balance between efficiency and the ability to pass moderate debris, making them suitable for many wastewater treatment scenarios. Finally, open impellers are designed specifically for pumping large solids without clogging. Since they lack shrouds, they have maximum passage size, which is a major advantage when dealing with raw sewage. The trade-off is a slight reduction in efficiency, but in this case, that's a worthwhile compromise for handling raw, unprocessed waste. Understanding these types helps us select the right impeller for each specific application, ensuring optimal performance across the board. Now, let's take a closer look at some of the critical components that keep a pump running efficiently. First up are the wear rings. These wear rings are essential because they separate the high-pressure zone inside the volute from the low-pressure zone at the impeller's eye. This separation is vital for maintaining the pump's efficiency and preventing recirculation losses, which can cause energy waste and damage over time. Next, we have the stuffing box assembly. At the top of this assembly is the packing gland, which houses either packing material or a mechanical seal. This setup acts as the pump's primary defense against leakage and air infiltration along the rotating shaft. Keeping this area sealed is crucial for maintaining pressure and preventing contaminants from entering the pump system. Moving on to the volute itself, this part houses the packing or mechanical seal and is also the pressure conversion chamber. Its distinctive spiral shape is designed to gradually increase in cross-sectional area. This shape allows it to efficiently convert the velocity head generated by the impeller into a pressure head, which is what delivers the flow to the system. Lastly, I want to briefly touch on the velocity head formula, which is V squared over 2g here. V represents the velocity of the fluid, and g is the acceleration due to gravity, which is 32.2 feet per second squared. This formula helps us understand the energy component associated with the fluid's motion, which is a key part of how we analyze and optimize pump performance. Understanding these components and concepts helps us appreciate how each part contributes to the overall efficiency and reliability of the pump system. Now, let's take a closer look at what we mean by advanced hydraulics for grades 2 to 4. Hydraulics is all about understanding fluids, how they move and how they stay at rest. This includes studying pressure, flow, and energy changes within piping systems and treatment processes. It's a fundamental part of understanding how water and other fluids are managed in various systems. One key concept here is the total head. Think of it as the total energy a pump provides to move the fluid. When the energy supplied by the pump exactly matches the energy needed to lift or push the fluid to a certain point, we call that the cutoff head. This is basically the maximum head a pump can develop when there is no flow, which is an important point to consider when designing or analyzing pump systems. Next, let's talk about how pumps can be arranged to work together. In a series configuration, pumps are connected one after the other. This setup mainly increases the discharge head, meaning it helps push the fluid higher or overcome more resistance. This is especially useful when dealing with larger elevation changes or longer pipelines where more pressure is needed. On the other hand, when pumps are arranged in parallel, they work side by side. This arrangement increases the flow rate without changing the discharge head. It provides a lot of flexibility and redundancy, which means if one pump needs maintenance or fails, the system can still operate efficiently with the remaining pumps. This makes parallel setups ideal for meeting varying demand conditions. Understanding these concepts helps us design more efficient, reliable hydraulic systems that can handle different challenges in water management. let's take a closer look at the energy transformations that happen during pumping. First, we have potential energy. Water stored behind a dam has what we call elevation head or potential energy because of its height. Think of it like stored energy waiting to be used. This potential energy can be converted into useful work when needed. Next, there's kinetic energy. This is the energy of motion. When water moves, whether through a pipe or a pump, it has kinetic energy that can do work, like turning blades or driving machinery. Then we have mechanical energy. When water flows through turbines, the elevated head, this potential energy is transformed into mechanical energy. That mechanical energy can then be converted into electrical power, which is essential for running the facility. Understanding these energy transformations is crucial because it helps us optimize pump selection, system design, and overall operational efficiency. This is especially important in wastewater treatment, where efficient energy use can make a big difference in both performance and cost. Let's take a look at some specialized pump types that are commonly used in various applications. First, we have split-case pumps. These pumps are designed to accommodate double-suction impellers, meaning water enters from two sides, which helps balance the hydraulic forces and improves efficiency. An important point to remember is that the number of stages in these pumps equals the number of impellers. So, if a pump has 3 impellers, it will have 3 stages, regardless of any differences in impeller size. Next, we have end suction pumps. One of their key features is their ability to rotate the discharge outlet 360 degrees. This flexibility makes them very versatile during installation, especially in tight or complex spaces. These pumps are most commonly used for general wastewater applications, particularly when dealing with moderate solids content, thanks to their straightforward design and adaptability. Finally, let's discuss chemical pumps, specifically diaphragm pumps. These are the preferred choice when it comes to handling chemical solutions. Their positive displacement mechanism allows for precise and consistent flow, while their design makes them safe for transferring corrosive materials without risk of contamination. This makes them ideal for chemical processing and other sensitive applications. Connecting all these points to our overall theme, understanding these specialized pump types helps us choose the right equipment for specific needs, ensuring efficiency, safety, and reliability in various fluid handling scenarios. Let's take a closer look at the shaft and bearing systems, which are vital components in ensuring reliable pump operation. The main purpose of the shaft is to transmit torque from the motor to the impeller, effectively converting electrical energy into mechanical rotation. Without a properly functioning shaft, the entire pumping process would be compromised. Equally important are the bearings, which support the shaft and keep everything aligned. Selecting the right bearings and maintaining them properly is critical for ensuring the pump runs smoothly and reliably over time. Now, focusing on radial bearings, they're responsible for maintaining the radial positioning of the shaft and handling loads perpendicular to the shaft's axis. These are the most common type you'll find in centrifugal pumps because they effectively support the shaft during operation. Then we have thrust bearings, which handle axial positioning. They manage the horizontal loads parallel to the shaft, especially the axial forces generated when the impeller rotates. Without these, the shaft could shift axially, leading to misalignment or damage. Modern centrifugal pumps typically use roller bearings because they offer superior load-carrying capacity, reduce friction, and generate less heat compared to older sleeve bearings. This makes them more efficient and durable over time. One critical fact to remember is that poor lubrication practices are a leading cause of bearing failure, accounting for 50 to 70% of all failures. That's why proper lubrication isn't just a maintenance task. It's the most important activity you can do to ensure your pump's reliability over its lifespan. Let's take a closer look at the main components of bearings and how they can fail. First, we have the essential bearing components. The inner and outer races are critical because they provide the running surfaces for the rolling elements. These races support the load and allow smooth rotation. The rolling elements, which can be balls or rollers, are responsible for carrying the load while reducing friction between the moving parts. Then there's the cage, which separates and guides these rolling elements, helping to maintain proper spacing and prevent contact that could cause damage. A quick note, rolling pin is not a bearing component. That's a common test question, so it's good to keep that distinction clear. Now, moving on to the major causes of bearing failure. The most significant factor is poor lubrication practices, which account for between 50 to 70% of failures. Without proper lubrication, bearings can overheat or wear out prematurely. Contamination is another big issue. Dirt, water, or debris can get inside and cause damage. Excessive vibration, often from misalignment, can also lead to failure, as it stresses the bearing components. Faulty mounting or installation errors are also common culprits, so correct installation is vital. Finally, it's important to remember that self-aligning, double-row ball bearings are quite good against radial loads, but they are only designed to handle very low thrust loads. Choosing the right bearing type for your application is essential for ensuring reliability and longevity. Let's go over some key procedures for component replacement. First up is the removal of the volute case. It's important to use a soft-faced hammer when removing the case at the gasket. This helps prevent any damage to the machined surfaces. Never use regular hammers, chisels, or screwdrivers, as they can cause scratches or dents that might lead to leakage later on. Next, when it comes to the impeller retention, remember that the impeller is held in place on the shaft by a small metal piece called a key. This key fits into matching grooves, or keyways, in both the shaft and the impeller hub. Ensuring this key is properly installed and intact is crucial for the impeller's stability and smooth operation. Regarding shaft storage, always store shafts vertically, standing on their ends. Horizontal storage, even if supported, can cause the shaft to warp or bend over time, which could make it unusable when you need it. Proper storage is vital to maintaining the integrity of these components. Finally, let's talk about wear ring installation. For casing wear rings, cooling them before installation makes fitting easier. On the other hand, impeller wear rings should be heated so they expand, allowing for a snug fit during installation. These steps help ensure a proper, secure fit, which is essential for maintaining efficiency and preventing leaks. By following these procedures carefully, we can ensure reliable component replacement and maintain the overall performance of the system. Let's take a closer look at packing systems and maintenance. The primary purpose of packing is to control water leakage along the pump's shaft. It's important to understand that the goal isn't to eliminate leakage completely, as some amount is necessary for lubrication and cooling of the shaft. When installing packing, a common practice is to stagger the rings at a 90-degree angle, which helps in achieving a proper seal and ease of adjustment. Now, moving on to packing materials, there's a variety suited for different applications. The most traditional type is asbestos-based packing with graphite, which has been widely used for years. For more modern applications, flax combined with PTFE offers a good alternative, especially in standard operating conditions. Asbestos-based packing is suitable for medium pressures and temperatures, while metal-braided packing with asbestos is designed for high-speed pumps and can withstand temperatures exceeding 450 degrees Fahrenheit. For chemical resistance and high-temperature environments, 100% PTFE packing is the best choice. It's important to note that packing is designed to wear and deteriorate over time with normal use. Typically, you replace it when further tightening no longer stops leaks. So, when tightening isn't effective anymore, not when the packing has completely disintegrated. This approach helps ensure reliable pump operation and minimizes unnecessary maintenance. Let's talk about seal water and piping systems. Seal water plays a vital role in cooling and flushing mechanical seals. This helps prevent overheating and removes any debris that might cause damage. Proper seal operation and longevity often depend on external seal water sources, especially under certain conditions. So, when do we actually need external seal water? Typically, when pumping chemicals, sewage, muddy water, or other dirty fluids. Also, if the discharge pressure is below 10 psi or if the suction lift exceeds 15 psi, external seal water becomes necessary. An important exception to remember is when you're pumping potable water. Since it's clean, it provides enough cooling and lubrication without the need for external water. Now, regarding seal water pressure requirements. If you're using external seal water, aim to maintain pressure 10 to 15 psi higher than the volute pressure. This pressure differential is crucial because it ensures a positive flow through the seal faces. Why is that important? Because it prevents the process fluid from entering the seal chamber, which could lead to premature failure and costly downtime. Connecting all these points to our overall theme, proper management of seal water systems is key to maintaining equipment reliability and efficiency. It's about understanding the specific conditions and ensuring the right pressure and source are used to keep everything running smoothly. Let's take a closer look at the different coupling types and how they align with various applications. First, we have the flange coupling. This type is particularly useful when you are working with shafts of two different sizes. It provides a rigid connection, which is essential for transmitting power effectively. Plus, it can accommodate size differences through custom machining, making it versatile for many setups. Next, there's the split coupling. This one is all about ease of installation and removal, which makes it ideal for maintenance tasks. You'll often see it used with vertical mounted pumps, especially in situations where access is limited. Its design simplifies the process of servicing equipment without extensive disassembly. Moving on, we have the flexible disc coupling. This type offers some flexibility, compensating for up to 2 degrees of angular movement and a 32nd inch of parallel misalignment. It also helps dampen vibrations while transmitting torque, making it suitable for systems where some misalignment is inevitable. Then there's the flexible diaphragm coupling. It handles even greater flexibility, managing up to 4 degrees of angular movement and a 1/4 inch of parallel misalignment. This makes it perfect for applications with significant misalignment potential, ensuring smooth operation and longevity. Now, I want to highlight a critical point regarding alignment. Centrifugal pump misalignment is a major factor, causing between 50 to 70% of all bearing failures. This underscores why proper alignment isn't just a technical detail. It's a vital part of installation and maintenance that can significantly impact equipment reliability and lifespan. So, understanding these coupling types and their capabilities helps us choose the right solution and emphasizes the importance of precise alignment in our overall maintenance strategy. Let's talk about lubrication fundamentals. The main purpose of lubrication is to remove heat and reduce friction in machinery. While preventing corrosion and minimizing wear are also important benefits, the core functions really focus on thermal management and friction reduction. When it comes to choosing the right lubricant, different applications call for different types. Water is excellent for cooling because of its high heat capacity. Grease is great for dampening shocks and handling heavy loads since it stays in place better. Oil is typically preferred for high RPM conditions and lighter to moderate loads because it flows easily and provides effective lubrication at high speeds. Additionally, calcium-based greases offer water-resistant formulations, which are useful in moist environments. Now, an important point to remember is how temperature impacts oil life. For every 20 degrees F increase above 140 degrees F, the lifespan of the oil can be cut in half. This highlights just how critical proper cooling and temperature monitoring are to maintain equipment efficiency and prevent failures. Moving on to some critical maintenance facts. Over-lubricating bearings can actually be harmful. More isn't always better. It's also vital to know that the fire point of a lubricant is the temperature at which it will ignite, so safety precautions are key. Never use animal oil on pump bearings because as it breaks down, it forms acids that can cause damage. And lastly, most pumps are not self-priming, so ensuring proper priming procedures are followed is essential for reliable operation. Understanding these fundamentals helps us keep equipment running smoothly and safely. Now, let's take a look at operational monitoring and testing, an essential part of maintaining our equipment's reliability. Starting with daily checks, it's important to monitor bearing temperature regularly. Listen for any unusual noises or vibrations. Verify that the seal water flow is proper, and keep an eye on packing leakage rates. These quick daily actions help us catch potential issues early before they become major problems. Moving on to weekly inspections, we should measure bearing temperatures with a thermometer, check oil levels, inspect for any leaks, and ensure the motor is operating correctly. These weekly checks give us a more detailed view of the equipment's health and help us maintain optimal performance. Monthly maintenance involves verifying bearing temperatures. Remember, about 180 degrees Fahrenheit is typical, checking the coupling alignment, and reviewing maintenance logs. Regularly reviewing these logs helps us track trends and plan future maintenance proactively. Quarterly testing is crucial for electrical health. Performing amperage and voltage tests on three-phase motors at least every 3 months allows us to detect developing electrical problems early, preventing unexpected failures. Finally, semi-annual reviews involve inspecting shaft and coupling alignment. Doing this every 6 months, or sooner if there are signs like excessive vibration or rising bearing temperatures, ensures our machinery stays properly aligned and efficient. By following these scheduled checks and tests, we support the overall theme of proactive maintenance, keeping our equipment running smoothly, safely, and efficiently. Let's take a closer look at some specialized pump applications. First up are regenerative turbine pumps. These are typically used in high-head situations where centrifugal pumps would struggle to be efficient. What makes them unique is their impeller design, which imparts energy to the fluid multiple times per revolution, making them ideal for those demanding applications. Next, we have screw pumps. These are most effective when lifting fluids less than about 30 feet. An interesting point here is that if you switch from a 2-flight to a 3-flight screw pump, you can increase flow by roughly 20%, assuming all other factors stay the same. That's a significant gain for certain operations. Moving on to submersible pumps, these are great because they almost eliminate the risk of losing prime. However, they do have a downside. You typically have limited access for maintenance or repairs. They're best suited for wet well applications where reliability is critical, and you need a dependable, sealed solution. Then there are recessed impeller or vortex pumps. These are designed to handle materials that would usually clog or damage standard impellers. The trade-off is that they tend to operate with somewhat reduced efficiency. The key point is that the impeller doesn't contact the pumped fluid directly, which helps prevent clogging and damage. Finally, we have turbine pumps. They're capable of generating very high heads, making them suitable for specific high-pressure needs. However, they do require more maintenance, especially when pumping large amounts of solids. Their line shaft bearings can be lubricated with oil or water, which is an important consideration for their operation and maintenance. Connecting all of these, each type of pump has its own niche, and understanding these differences helps us select the right pump for the right application, ultimately improving efficiency, reliability, and cost-effectiveness in our systems. Let's now look at some common problems you might encounter and how to troubleshoot them effectively. First, priming failures. A typical issue is when the pump fails to prime because the suction lift is too high. This often happens when the pump is placed too far above the liquid level or if there's an elevation difference that makes it hard to draw fluid in. To fix this, you should reevaluate the pump's requirements and correct the condition. That might mean relocating the pump to a lower position, installing a booster pump to help push the fluid, or redesigning the system altogether to reduce the suction lift. Next, we have prime loss issues. Sometimes, a pump can lose its prime because air gets trapped in the suction line. The key here is to open the air bleed-off valves on the suction piping to release any trapped air. Additionally, ensure that the piping has the proper slope. This helps prevent air pockets from forming. High points in the piping are especially problematic because they tend to collect air, so eliminating or properly draining those high points is critical. Now, let's discuss excessive upthrust in line shaft turbines. This problem often occurs when the pump is moving more water than it was designed to handle. Overloading causes the shaft to experience too much thrust, which can damage bearings or other components. To address this, you should throttle the discharge valve to reduce the flow to the pump's designed range. Also, check the impeller size and wear condition. Worn or oversized impellers can contribute to this issue. Finally, on mechanical seal replacement. It's important to remember that seals should only be replaced when leakage becomes excessive. Some minor leakage, say 1 or 2 drops every few minutes, is actually normal and helps lubricate the seal faces. Replacing seals prematurely can cause unnecessary downtime and expense. Only replace them when the leakage is significant enough to affect operation or safety. By understanding these common problems and their solutions, we can keep the pump system running smoothly and efficiently, which is key to the overall success of our operation. Let's wrap up with some key takeaways to ensure your success in certification. First, mastering the fundamentals is crucial. Understanding basic hydraulics, things like pressure head, friction head, velocity head, and pump head, really forms the foundation for everything else. Knowing the formulas and when to apply them will give you a solid base for more advanced concepts. Next, it's important to know your components. Be able to identify pump parts by their function, where rings, for example, separate pressure zones, packing controls leakage, bearings reduce friction, and the impeller type directly impacts solids handling capability. Remember, your knowledge of these components will be heavily tested. Third, understanding maintenance priorities can't be overstated. Poor lubrication is responsible for 50 to 70% of bearing failures, and misalignment causes another 50 to 70%. Focusing on proper lubrication and alignment should be at the top of your maintenance checklist. Fourth, keep the key numbers in mind. You'll see these values repeatedly: 30 inches of vacuum, 34 feet of water column, bearing temperatures around 180 degrees Fahrenheit, seal water pressures between 10 and 15 psi, a 90-degree packing stagger, and a 50% reduction in oil life for every 20-degree increase over 140 degrees. Memorizing these will help you troubleshoot effectively. Finally, always study the references. The questions in certification exams often point to specific pages in books like Pumping by Spellman and Drinnen, or Pumps and Pumping by Aerosmith. Reviewing these materials thoroughly will deepen your understanding and give you the detailed explanations you need. Keep these points in mind, and they'll serve as a strong foundation for your success.